You're about to find out.
Does he just instantly start spiraling, say dumb shit?
Does he get upset?
It's something like that, but people
that
could
sounds
change.
pretty dismissive, honestly. I don't know.
Well, does he get upset? Like, did he invent the Goldberg theory? He's like mad because we're shitting on. Well, I was just saying, is he mad because we're shitting on his theory? Is that why he's upset?
I think so.
Yeah, something like that.
Oh, we found the inventor of the Goldberg theory.
Yeah. So do you wanna talk about science, or
is the shape of the Earth a scientific question?
Quite literally, yes. It has to do with It has to do with physics. It has to do with
science me a basketball. Science me a tennis ball, and a science me a basketball.
No, I don't think you understand what that means.
No,
so it has physical implications, right?
Bro,
it has implications in scientific field.
Okay, so give me the physics of a shape.
The physics of a shape? Shapes don't have physics. Don't have physics per se. Wait. Actually, I don't know. That's kind of a weird question. But anyway.
Stop interrupting me, prick. Okay, you just said the shape of the Earth was science and physics. And then I asked you, what's the physics of a shape? And you scoffed. You said it, dumb fuck.
Okay, so you know how shapes determine, like, for example, like the way that gravity would interact with the body. Yes. So, for example, okay. So, have you ever heard of Gauss's law?
Yes, we've heard of Gauss's law.
Yeah. It's electromagnetism, but electromagnetism is well known to have, very clear. It's. Let me finish, please. Okay.
You're not educating, dude. Get off your high horse. You're not educating.
Can I please?
You're not educating anybody.
That's fine. So
we know what Gauss's law is. We know what Gauss's law is.
Electromagnetism has pretty clear.
You're talk over me. You just gotta get out your bullshit.
It has parallels with gravity, you know. So one thing that you can do, let me please get to my point.
Dude,
so Gauss's law, you can use Gauss's law to determine more or less what the gravitational acceleration would be based on the shape and mass of the Earth. Now, if you input those informations, right, like if you use the Earth as a sphere, it more or less gives you a result of 9.81. If you use it as a flat surface, as a flat infinite surface, that like completely messes it up. You can do your calculations.
First of all, you're lying.
No, I am quite literally not. You can do it yourself.
I'm going to post a paper right now that's peer-reviewed that shows that Gauss's law, when applied to a flat Earth, works. And what are you going to say then, stupid fuck?
Okay, sure. In that case, I guess
I'm going to post it. I'm going to post it in the chat right now.
Yeah.
Okay, so we can get rid of that.
No,
I don't think we can. I would like to read the paper before I accept it.
Because you think we don't know anything. It's you who don't know anything.
Quite literally not making shit up. But if that's what you like,
you are, because what you just said, if it not working on a flat Earth, is just a straight lie.
Well, no, it's not. You can quite literally do your own.
It doesn't tell
you can quite literally do your own calculations.
Gauss's law is an integral, right? It'll tell you the line element. You take the line element, and it'll tell you the normal vector of gravity, but it isn't going to tell you the acceleration at that point.
You understand that if you take a force and you divide it by, like, the thing is, if you take a force, you can always derive an acceleration from it. Yes, like if you know the mass of the object that it's interacting with.
Gauss's law only tells you a direction.
No, it doesn't. It tells you the magnitude.
You don't understand.
That's false. That's false. That is false. It gives you the magnitude of it.
Dude, you can try to keep talking over me. You don't know what you're talking about. Okay? You have no clue.
I think you just demonstrated that you're the one who doesn't know what they're talking about.
Yeah, okay. So I'm gonna show why you don't know what you're talking about. So say I have a mass of, let's say we'll just use mass, and we'll use 1 as a unit. Okay? What's the total amount of mass on the Gaussian circle, on the Gaussian surface of the sphere that surrounds it, no matter how big it is?
Wait, sorry. Can you repeat that? I didn't understand the
The
question.
mass the mass of the test particle is 1 unit.
Mhm.
The force that exerts, it's 1. We're just going to use it as 1. Now, if I enclose it in a sphere, what is the force of that's on the entire surface of the sphere?
On the entire surface of the sphere.
Yes.
So on the inside, it's going to be 0. On the
It's
outside, like
gonna be
immediately on the outside, it's not going to be 0. It's going to be like a different number depending on
It's
how
also going to sum to 1.
close it is.
It's also going to be 1. You don't know what you're talking about.
No, on the inside, it's not going to be 1. On the inside, it's going to
No,
be 0.
I didn't say I didn't. First of all, the inside of what? The inside of the surface of the
On
sphere.
the inside of the sphere, yeah. If the sphere is, if
Dude,
it's a
the
hollow sphere,
force
it's going
is
to be
equal
0.
to the force of the mass enclosed, dude. What the fuck
Yeah.
are you talking
So
about?
the mass enclosed. Yeah. So if you have
The
a
mass
hollow
enclosed
sphere,
is 1.
the mass
The entire
enclosed is going to be
surface
0. Yeah, that's the point.
The mass-
If you have a hollow sphere, the mass enclosed is going to
Yeah.
be 0.
I just said the mass inside is 1.
No, the mass inside. Okay, so if you have a,
This is a hypothetical, dude.
a hollow, if you have a hollow sphere, right?
You're gonna watch
The way you apply Gauss's law is you will have to take a smaller radius than the radius of the sphere in consideration. Okay, and on the inside, the mass is going to be literally 0, right? Like in that on the Gaussian surface, it's going to be 0. Outside, it's not going to be 0. It's going to be 1 in that case. No, that's going to be on the outside. That's going to be on the outside.
You know what you're talking about. Okay, so it could be radius 1, radius 2, radius 5, radius a gazillion. The total amount of force on the surface of that sphere is equal to the mass enclosed.
As long as the radius that you're considering is larger or equal to is larger than the radius of the sphere itself. Otherwise, it's going to be 0.
You're embarrassing yourself, stupid.
I quite like you can literally look it up right now.
You got a fucking D- in mathematics.
Uh-huh.
A fucking D-.
So, do you? First of all, that's not okay. First of all, that's not a matter of math.
Is it equal to the mass enclosed? Yes or not?
Integrals are math, but the integrals are math. But what we're discussing here is the distribution of what we're discussing here is the distribution of the mass.
Is the force
and that does not concern math. I'm sorry.
Okay, is the force inside the sphere? You're just yapping. You're just yapping and saying nothing. Is the force on the surface of the sphere equal to the force exerted by the mass that's enclosed by that sphere?
Sure, yeah.
Yeah, okay. So you cannot derive 9.8 meters per second squared from the force because it doesn't matter what size of the fucking radius it is because you're doing line integrals, you stupid fuck. You're doing integrals.
No, it does not have to do anything with that. So the thing is, obviously, if you take...
Tell me what an integral is.
Yeah.
You have 1 second.
What an integral is? Okay, so an integral an integral is going to be the inverse function of a derivative. If you want to think of it.
Yeah, but what is it geometrically?
Geometrically.
What is it geometrically?
It calculates. I'm telling you, the area under the graph of a function.
Okay.
I know this stuff, bro. Like it's yeah. So okay.
And how does that line integral, tell you the force at that point?
Yeah, that is derived by
how does
by
that
the laws
tell
of
you the acceleration at that point? How does it tell you the acceleration at that point?
How does it tell you that? So again, are we calculating a force?
Yeah, why you're repeating my question? How does it tell you the acceleration at that point?
So what are we what are we calculating with Gauss's? Yeah, with Gauss's law, what are we calculating? Do you know?
Dude, it's your claim, dude.
What are we calculating? Do you know what we're calculating?
Well, you said on an infinite flat Earth.
Okay, so you don't know what we're talking about. Is that correct? So your
initial claim was.
You're now attacking an argument that you don't understand. Is that correct? Okay. You're attacking a point that you don't understand.
I'm going to answer. So now you're muted because you're not letting me answer your question. So
take your time to mute me.
Oh, I can't mute you? Yeah, I can. So, really simple. Okay? You came in, your claim was you can use Gauss's law of gravitation in the mass of the Earth to derive the acceleration of 9.8 meters per second squared acceleration. Then you said if you do that on even an infinite flat Earth, it messes up. That's what you said, verbatim. Now, is that what you said?
Sorry, I wasn't listening. I was zoning out.
Oh, you're banned now. So
Classic.
yeah, we don't.
Yeah, bro. I don't know.
Yeah, we don't play that game. You came to the wrong place to play games.
Yeah, that's trash,
So
bro.
while you're here, look in the chat. Look in the chat. What's that say? We discussed the flat and hollow models of the Earth as a pedagogical example of the application of Gauss's law in the gravitational field. Now I'll post the actual document and cook you some fucking more.
Go ahead, Kane.
Uh,
Oh, am I unmuted? Sorry. Okay, I thought you were. Okay, yeah. So let's see.
We're going to talk about being
yeah,
muted.
so look in the chat.
Models T towards.
Fuck.
Okay. We discussed the flat and hollow models of the Earth as a pedagogical example of the application of Gauss's law to the gravitational field. Okay, let's look at the paper.
Yeah, you can just scroll down to the flat Earth part, right?
Yeah, sure. It's fine. Do you? Oh wow, that's 4 pages long. That's very short. So
Yeah, even you'll understand it.
sure. So blah blah blah. Let's just say it's okay. That's what I gravitational constant. Yes. Okay. So where do we get to the part where? Okay. The flux through the surface is gonna be this. Yep. Okay. So that needs to this. Okay. For the field inside the distribution, of the evaluation of the field outside the distribution. Okay. Oh yeah. Okay. Obviously, we're not considering a hollow sphere. That makes sense. Proceeding to the same way. Blah 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 blah. Follows Gauss's law. So it's a mass distribution. Fine. Okay. What if the flat is flat and hollow? What if the Earth is flat and hollow? In this case, the render can easily verify the gravitational field reads. Okay. So what is H gonna be? I skimmed through it, so it was in. So what is H gonna be? As I assume it's like the radius of the Earth? Question mark.
What is what? I should just
So
tell you I
do
wasn't
we-
listening.
Yeah, so I was skimming through it, so I didn't read everything. But what is H going to be in this case? So it says it's going to be 4 pi g sigma for x less than or equal to minus h half. Okay, must reproduce the measured value of the gravitational. In that case, if the Fermi model resembles Asker subsequence. Oh, it's the thickness. Okay, compares the radius r of the spherical Earth, the mass. Blah blah blah. Since g must be equal to the gravitational acceleration on the surface of the spherical Earth, we have this where r means blah blah blah. It follows that. Okay. Okay, notice that this result does not depend on the mean density of the Earth. If the Earth were a lighter or heavier planet, this would still hold. As a consistency check, the reader can infer the value of a rho from the measured value of g on the surface.
Yeah. Now, what was the point of this? You saying we use Gauss's law of gravitation? It doesn't make any sense to the flat Earth. You just made that shit up. But here's the crux of the problem. Said gravity forms balls. Give us a single observation of that happening in the natural world, just once. Because science is empirical. It's not a bunch of stories. You and your DMs, Kane? You phoning a friend? Oh, you dropped.
Wow.
Yeah, he just got cooked.
That
I'm
needs to
using the
be
chat for
saved.
Indio.
That needs to be saved.
W.
Yo, good shit, Indio.
Oh yeah.
That last
Dude.
2 minutes. That
Dude,
last 2
he
minutes.
tried to
you know what I mean?
bamboozle, man.
I'm gonna
He
save
tried to
that
bamboozle.
citation. Or paper.
Dude, I've had this for years now. Like, they're like, how would gravity work on a flat Earth? Oh, like this. Now they want to change the subject. I don't like bringing it up because I don't even want to give them that. There's like no evidence for it anyway. Like, why would I fucking want to play in that playground?
You know, I can see Kane right now. He has his fingers interlocked and his head is just resting on his hands right now, staring up into nothing.
Never going to come back.
That's it, man. He's done.
Yeah, that water drop, it's a drop form because of the air pressure around it pressing on it from all sides. Isn't that crazy? Because gas is going all directions.
Or do you just skedaddled? That was fucking hilarious, yeah.
Dude, he
Oh,
was
he's back.
just pissing me off, dude. He was just like stop talking all over me, man. It's ridiculous.
Indio, your boyfriend's back.
Who?
Kane.
Should change his name.
It's him?
His little grandson. Indio, he's came back, bro.
Yeah? Falling in my court? Any observations of gravity turning things into balls? Anywhere in nature that ever happened? Even once.
Oh, he's muted. You guys cool if I unmute him? We'll continue the conversation with Indio.
Dinosaurs. Brit knows this one. You just start yelling anything to answer Indio's question.
Oh, hello. Sorry. I was like my connection just died for a minute there. I was reading through the paper. Yeah. So what I see this does is that it tries to account for the shape of the Earth, like how thick the Earth would be in order for G to be the correct number, and that's fine, I guess. So what does that have to do with anything?
Okay.
So does it work on flat Earth?
What is it?
Does it work on flat Earth?
Well, yes and no, I guess.
Oh, so both. It does, and also at the same time, it does not. Wow.
Well,
Oh, it does, but because you don't think
no.
it's
See,
flat.
there's a little problem. No, okay. Actually, whatever. I don't know. Sure. I mean, I can look at this.
We know what the problem is.
Huh?
A flat earther said it, so we know what the problem is.
No, I don't have a problem with that. G must be equal to a gravitational acceleration on the surface. We have. Okay. R is the mean radius. I'm just trying to read through it carefully so that like if there's a mistakes or stuff like that I can. But I mean, it's hard to mess up this stuff honestly. So
Crux of the argument is on a correctly shaped flat surface, the gravity vector would be identical to a fucking ball. You wouldn't be able to tell the difference.
no, again, it's not exactly true.
From the surface, it would be identical.
No, what it's saying is that there is a certain like thickness like that the Earth would have to have in order for this to make sense, right? So basically that is, or I think it also depends on like the mass concentration, but yeah, in a nutshell, what it's saying is if the Earth was this was flat and this thick, then yes, it would work.
Thick.
What does mass have to do
So
with anything?
H is the mass has to do. What do you mean with it has to with anything? It's
Well,
gravity.
define mass. Define mass, please.
Gravitational. Yeah,
Excuse
mass is
me.
The amount of
Define mass.
is the amount of matter contained in a body. So
correct.
That's incorrect.
that's incorrect. Sure. So what is mass?
Once, pay
Are you gonna say it's like weight? What are you gonna say? Like what? So what is mass?
It's currently defined as resistance to acceleration. It's not a quantity of matter. All definitions of that
It's not a quantity of matter. Okay, that's very
That
interesting.
have been shown to be false.
Okay, sure.
Quantity of matter does not give you the mass.
Yeah, you understand
You want
that.
citation? You
like
want citation? Do you want citation? So you don't think it's
Like one
methane?
citation. Yeah, sure.
Watch, I'll give you 3. Hold on.
What is density? Do you know what density is?
Yeah, who cares? Define mass. We want the actual
who cares to
scientific
find
evidence.
mass? Yeah, okay. So does density change?
No, you're trying to get out.
when we this density change, like does the density of a body change when the mass of the body like increases, for example? But the like the what's the word? But the volume of it doesn't, right? Like, does that happen? If so, how do you increase the mass of the body? By to increase the mass of the body, you can add matter to it, right? Do we agree with that?
We don't even know what mass is yet. So why are you bringing mass into this equation?
Do you know what matter is? Do we know what matter is at the very least?
Now we're going to material. Okay. Give me your definition of material.
Give me your definition of material. Okay, so
Yeah.
yes, okay.
Hey, Kane, you're obviously way out of your league here. Like, you're way above your pay grade. That's why you have the nervous laughter and repeat the question that we ask you. So it would behoove you to just humble yourself, obviously realize that you're way outgunned, and learn something. Or, if you continue to talk through people and ask the question again, not give citation, not give correct definitions, it's going to be a really long day for you.
Damn.
In ordinary language, the word mass